Let's imagine how cool it would be to have a forearm that can be deformed like Rubberman. To make it real, we explore the sensation of arm deformation in VR. We conducted 3 perception studies using ArmDeformation box. We confirmed the optimal number of actuators, and the ideal skin-stretching design effectively increases the user's body ownership. Additionally, we explored the maximum visual threshold. Based on our perception studies, we designed ArmDeformation, a wearable skin-stretching device, for enhancing virtual forearm ownership during arm deformation illusion. Using ArmDeformation, we conducted a JND study and found the rotational JND of the bending direction. Lastly, our final study demonstrates that using arm deformation in VR applications enhances user realism and enjoyment compared to relying on visual feedback alone. To create the illusion of arm deformation, we use 30mm diameter silicone pads to stretch the skin on opposite sides of the forearm, and the maximum stretch is 20mm. The video shows the forearm bending upward and downward, elongating and shortening like the rubber arm. To render bending in an arbitrary plane, the rotation subsystem can rotate the actuators in opposite positions on any side of the forearm with a resolution of 1 degree. This auto-adjustment subsystem allows arm deformation to adapt automatically to the shape and size of the forearm. The skin-stretching subsystem induces the illusion of the forearm bending upward or downward by moving the silicone pads in opposite directions. Also, it can induces the illusion of the forearm elongating or shortening by moving the silicone pad in the same direction. In the baseball scenario, users can sway their forearms to catch and throw the ball. In the boxing scenario, users can elongate their forearms to hit the sandbag. In the tentacle application, users can control the tentacle bend as if they own it. In the remote click application, users can control the home devices by elongating their forearms.